So the next thing to do will be to find what is called the correction factor. So this is the correction factor. So the correction factor is simply equal to the grand mean square divided by big N. So you can see, to make sure you don't forget the setup. So that's the first thing to do. Let me write this here. After getting this table, the first thing to do is find the correction factor. So we already know this as 1042, then we square it, divided by big N. Big N is simply the number. So big N is simply the number of entities here. So if you count, we have 15 entities here. 1, 2, 3, 4, 5, 6, like that all the way. Everything here is 15. Not the sum, or not 82 plus 80. No, the entity itself. This is one entity. This is 2, 3, 4, 5. So if you add everything, 5, 5, 5, that is 15. So that is what they refer to as N, not small n. Remember, this is small n and big N, they are not the same. Small n is just 1, 2, 3, 4, 5. That's for small n. For big N, we're referring to 5, 5, 5. So if you do this, you get 7, 2, 3, 8, 4.3. So if you do this, you get this as a correction factor. So the next thing to do is to find the sum of squares. So we have the sum of squares. Remember, we're talking about sum of squares not too long. So this is the second thing to do, to find the sum of squares. So to find the sum of squares, let me just put this here. This is for this. So to find the sum of squares, we need to find the sum of squares total, the sum of squares between, and the sum of squares within. Very simple. So the sum of squares total, this is not the sum of squares total, this is just the what will help us find the sum of squares total. So what we do is we take, so the sum of squares total is equal to the 74756 minus the correction factor. Do you see it now? So we take this 74756 minus the correction factor 72384.3. Sum of squares total from this, we'll get this. So that will give us 2371.7. So that is the answer. Now, for what about the sum of the SS between? The SS between, as you can see, will now be this guy here, will now be this guy 72552.8 minus the correction factor. You can see how simple this is. So that is 72552.8 minus the correction factor, which is 72384.3. You get 168.5. Now the sum of squares within, you don't need to stress yourself to get that. The sum of squares within is, we have the sum of squares total, we have the sum of squares between. So the sum of squares within will be this minus this. So let's subtract 2371.7 minus 168.5. You would get, so let's write it here, 2203.2. Alright, so you can see that we've gotten our SST, SSB, and SSW. Now I erased mine, like the ones I put here before. Like I said, once you've gotten your SST, SSB, and SSB, just erase them. So you just erase them, because this is not SSB, it is not SST and SSB. This is SST and SSB. So erase them with your eraser. Write them in pencil first and erase them, just like I have done. So the next thing to do is to find what is called the degree of freedom. I'm sure we're already familiar with that one, but this one goes a little more. So this is the degree of freedom. Very simple too. This is the third step to find our degree of freedom. And of course, we find our degree of freedom total, degree of freedom between, and degree of freedom within. Very, very simple. So the next thing to do is to find the degree of freedom total, and the degree of freedom total by default is n minus 1. Notice I did not use small n, I used big N. There's a difference between small n and big N, like I said before. Big N is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so 5, 5, 5, that's 15. So degree of freedom will be 15 minus 1, which is equal to 14. So this is our degree of freedom total, 14. And then it is 14 because, like I said, it's n minus 1. And this is n here minus 1 because that means we're dealing with a one variable Anova or one test Anova. So, but don't worry about that. Let's move on. Next is degree of freedom between, and of course degree of freedom between, we're referring to the column. So we have column 1, column 2, and column 3. The column 1, column 2, column 3 minus 1. So we have how many columns? 1, 2, 3. So that is 3 minus 1, which is 2. Now degree of freedom within is just the 4, because we have degree of freedom total, degree of freedom between, just like we did for SS. So 14 minus 2 will give us our 12. Very simple. So we just subtract this from this, we get 12. That is it for degree of freedom. Let's move on to the last one. So the last one is to just find our mean sum of squares. So to find the mean sum of squares, very simple. And this time all we need to find is just the mean sum of squares between and the mean sum of squares within. Let's find this one first. The mean sum of squares between, this is the last step. The mean sum of squares between is the SS between divided by the degree of freedom between. So all we are doing is basically finding the degree of SS between divided by degree of freedom between. Very, very simple. So let me do it here. It's just 168.5 divided by 2. Then the next one is our SS within. Of course, you already guessed it. The SS within is just the MSS within, sorry, is just the SS within divided by degree of freedom within, which is degree of freedom within is 2203.2 divided by 12. So this value here will give us our answer. So I already did mine and the answer is 183.6. So this is our SS between and our SS within. The answer, which is the last step, I'm not counting it as a step because this is already our answer, to find our F calculated. The final, like every single thing we've been doing here, is to arrive at this guy, very troublesome guy. So the F calculated is very simple. The F calculated is just the MSS. Let me just separate this here. It's just the MSS between divided by the MSS within. So all we just do is just divide this by this. Very simple, right? So that will be 84.25 divided by 183.6. I already did mine and the answer is 0.46. So that's my answer. Okay, so this is our final answer to all those procedures I went through just to find the F calculated. Now, what about the F tabulated? That is from the F distribution table. So we need to go to the F distribution table. If you remember in the question, with a 5% level of significance or 0.05%. So we need to find this. But we need extra two values to find this, to find the tabulated. We need to find what is the degree of freedom between and what is the degree of freedom within. So we need these two values to check the table. That's all we need. Very, very simple. So if you remember from our question, our degree of freedom between is 2 and our degree of freedom within is 12. So let's go to the table so we can find this and with a 0.05. So that means that we're looking at the F table for 0.05. Make sure you don't go and look for the F table for another degree of freedom, they're asking you for the F table for 0.05. So that is the table I'm going to use now. So this is my own F table, and remember the question says alpha, or the level of significance, is 0.05 here, sorry, 0.05. So that means my F table should be 0.05. Please check very well. If the F table you are using is 0.0 something, please don't use it. It's not what they're asking you for. So the degree of freedom between and degree of freedom within. So our degree of freedom within is 12, and our degree of freedom between is 2. So that means we have to check here for 2 for degree of freedom between and degree of freedom within 12. So we're looking for this guy here. So if you trace it, you will find it here. So as you can see, our tabulated degree of freedom is 3.89. So it can be 3.88, depends on your approximation, but it's okay like this, 3.89. So now you can see that the F calculated is not greater than or is less than, it's not up to the F tabulated. So we must accept the null hypothesis. So we must accept the null hypothesis. The null hypothesis is correct. Remember the null hypothesis says that this and this and this are equal, meaning that no matter the department you are, it doesn't affect your grades in CBS 221. You can be in economics, you can be in accounting, you can be in banking and finance, and you still score the same grade. If economic students move to banking, they will still score the same grades. Their department does not affect them, and that is what the null hypothesis is claiming. So the null hypothesis is correct, and we must accept it because the F calculated is not greater, is less than the F tabulated. So the F calculated is less than the F tabulated, and that's the answer. The null hypothesis is correct. So that's it for this video, and I'll see you guys in the next.